We have to get a surprise for it at least.
Hello!
Oh, sorry.
I don't know why I chose to do like Mrs. Doubtfire just then. Right, welcome back, guys. So yeah, we're going to jump straight in with Jonathan Barrett. So,
Thank you very much.
where you go?
Yes. Hi, well, thank you, Alex, for inviting me along. And yeah, the plan is to talk about software as a service businesses. Kind of how to start one, how to build one, how to grow one. So, let me see if it works. So, a quick disclaimer. Imposter syndrome. Okay, be gentle with me with questions. Okay. Every morning I wake up and it's like I'm starting a new job for the first time. It's a bit weird. I have been doing it for 17 years, so I should be okay, but nevertheless. Alex said no sales pitch. That's cool, because I've got nothing to sell. only a bit of experience to share. She said make it techie. It's sort of techie all the way through, and then there's a bit of techie, proper techie stuff right at the very end, which you guys are going to be able to answer my questions, hopefully. So, where do we start? Right, so the agenda, I'm going to whiz through these things. I'm not even going to stop at this. The idea is I'm going to blast through these as quick as I can, and then hopefully do lots of questions and answers at the end, and we can come back if necessary. So, how did I end up? Just a quick bit of background. So, I started my career in product design. I'm an engineer, really electronics and mechanical engineer. I ended up writing about engineering. So I got into the publishing industry writing about engineering. And then at a point in the history of the publishing industry in the UK, the internet had kind of fractured the publishing sector. Centralised offices were dispersed, people were working from home, remotely, etc., etc. And we were having all sorts of trouble communicating. Running a magazine is a team business. How do you do that efficiently and effectively? It was getting a bit of a problem. And I woke up one day and I thought, I wonder if there's a better way. And so I grabbed a friend of mine who was a developer, and I sat down and said, is there a way we could do this? He said, nah, there probably is. And that's where it all began 17 years ago. The way I'm going to present this, I'm going to do it as snakes and ladders. The snakes are the things that push our business backwards, and the ladders are the things that allow us to move forwards, and then a little anecdote sort of thing. So the history of software as a service, I call it dematerialising the world. So it's where you find a little problem, a little niche problem, typically in the real world. You wonder if you can dematerialise it into a process, turn that process into code and then share it, and then hopefully sell that benefit to someone. That's my interpretation of it. So if you see a problem, just wonder whether you could turn it into a little minimum viable product, just an explainer, and then share it with the world, and then someone might say, oh, that sounds like a good idea, we'll pay you a bit for that. And then that may be the beginning of that journey, as it was for us. So the snake here was, I nearly didn't bother. Right? Someone else will sort that out. I'll just wait till another development team will suss that, and then we'll just buy what they do. But no one did. And we thought, we'll give it a go and see what happens. What's the worst that can happen? And then once you've tried and it has kind of worked, you suddenly realise you could probably do it again regarding each problem you encounter. So why SaaS? I don't want to work in any other business because it just is a beautiful business to be in because all the effort's up front. So if you commit to a year of hard work, from there on in, if you've got it right, it can be a really nice ride. Fairly relaxed, fairly straightforward, you're into maintenance and support, and then it just rolls. It's a lovely business model, in my humble opinion. It scales well. You'll see in a minute, the particular application we developed is in nearly 60 countries of the world, just because there are people there that it helps. So it scales up really neatly. It aligns with subscription payments, so small repeat payments. Small repeat payments are reliable and secure. It's low maintenance, as I say. If your hardware's working well, the code's debugged and working well, and your feature set is what your customers want, it kind of rolls. It just rolls along. Fingers crossed. So here's the interesting thing. So we nearly launched on a 3.5 floppy. I don't know if anyone even remembers those. Because at the time, software as a service, cloud, well, not even cloud, I mean the word cloud hadn't been invented, hosted applications were very new. And one of the interesting things there is, at the time, there was no insurance for a software as a service product, because no insurance companies knew what they were or what to do with them. And there were no terms and conditions. You couldn't just go to the internet and buy a set of terms and conditions from a software as a service company, because they didn't exist. So we had to get lawyers to write service terms and conditions. We had to get insurance companies to work with us to create insurance policies, which was just a crazy sort of time. And here is probably one of the most important things. You end up with a diversified customer base, by geography, by size, by type, by interest, by payment level. We've been through two gigantic global financial crises, back in 2008 and the recent one with the pandemic, plus the pandemic itself. And our diversified customer base is what got us through. Because what's going on in the UK is not what's going on in America, it's not what's going on in Asia, it's not, and it all kind of smooths it out. It's a really good survival tactic, should I say. On our website we have stats running live. That's what a very small niche software as a service app, KPIs, key performance indicators, looks like. That's us as of today. I took that screenshot earlier on. It's a planning tool for magazines, so 16 years running. It's operating today in 59 countries. Today we're running at 7,900 users and 4.5 million pages planned over that period. And it's a team of 2 or 3 people. So that is what 16 years worth of tiny niche SaaS can achieve. Some people might think that's impressive, other people think it's rubbish, but we're kind of happy with it. It's fine. So, start with a minimum viable product. You've spotted a problem. You're considering coding up a demonstrator or some description. What is it? So, a date must be chosen by which you release the beast into the world. Okay, the application. It's a terrifying day. It's called a minimum viable product. But there's a problem with it, which is that everyone in your team will have a different idea of what constitutes your minimum viable product. Okay? Whether it's the developer, sales guy, business development, marketing, blah, blah, blah. Everyone's got a different idea. And that leads to mission creep. And mission creep is deadly for a SaaS application. It just drains money, it drains time, you have to kill it. So it's never quite ready. But all you have to do is pick an immutable deadline, an unmovable deadline. And what we have a habit of doing is booking a stand-up show where we're going to launch the product, whatever it looks like. Okay? And it is a fascinating thing. When we launched our first SaaS application as a minimum viable product at a national exhibition, everyone thought it was a finished product. Obviously, yeah, great. Yeah. And it almost was. It took about another 2 years to become a finished product as customers demanded certain features, etc., etc. But that's kind of how it went. Pricing is absolutely everything, because there's no point in doing it if it's going to make you a loss. So you have to get pricing right. What's good about software as a service is you just get to test the pricing. Okay? And if you get it wrong, you run your pricing for a week. So you launch it on a Monday, you run the pricing for a week. If you haven't got very many customers by Friday and they're all complaining about the price, change the price the following Monday. That's what we did. So we thought, before we launched our first application, that the perceived value was somewhere up to £1 per credit, because we were selling things called credits. It turned out what we call the waterfall value, which is where no one's buying, no one's buying, no one's buying, no one's buying, everyone buys, turned out to be 35 pence. Don't ask me why. Okay. That's what our industry considers our product worth. And we just ran tests and ran tests and ran tests and ran tests. And then we just noticed that waterfall event where people started to buy. And what's interesting is we don't sell packages. A lot of software as a service businesses kind of sell defined packages. We just let you buy credits, a bag of credits, and you can then exchange those credits for the services we provide. So our pricing system stays the same. We never really change it. All that changes is how many credits it takes to access a certain service. So it's really quick to add new services because you don't have to set up new pricing processes and that sort of thing. It's a little bit like when you go to a fun fair and instead of paying per ride, you buy a bag of credits and exchange them for each ride. It's kind of what we do. So it works for us. Onboarding. Onboarding can be a real problem. Because it can stall your launch. I'm working with a couple of companies at the moment that are kind of in danger of being in that loop.
Sorry, what's onboarding?
Oh, bringing new customer on board.
Oh.
Yeah, sorry. Yeah, so yeah, if any of these terms aren't making any sense, stop me. Yeah, onboarding is the process of getting a new customer into your system and working with it efficiently. Yeah. So it can overwhelm the launch of a product. If the effort is too high to get a new customer into the application. So the thing, the same thing here. You should be able to measure almost in seconds the amount of time it takes to register a new account and for your customer to be able to do something productively. If they need to go to a manual, then there may be a problem with the interface. We never really wrote a manual for our products. So the reason that typically happens is that when you're in that coding mode, when you're in that programming mode, when you're in that test mode, you have to place yourself in the seat of the customer, because what might be acceptable to the programmer or the strategist or the test engineer or whatever might not be acceptable to the user, and so you need to be careful you don't fall into that trap. The single biggest thing that we stumbled across beneficial is group Zoom tutorials. So if we've got a customer that's got, say, 20 or 30 people that might work on our product, we just Zoom the whole group all together in one hit. It's super quick, everyone takes notes, and 9 times out of 10 we don't get back. That's about an hour. So say we do an hour's Zoom tutorial, covers 20 or 30 people, chances are that's the only thing we need to do. And obviously that's a whole pandemic type shift, and that really worked quite well. We are producing tutorials. In fact, we're just about to do a big new tutorial section, but that's as much about marketing as it is actually using the product. Because tutorials act as a great sales tool, because you can just dip in, see how something works. If it looks like it works the way you'd like it to, then you might register and try the product. So that's our kind of view on that. Going native. This one cost us 2 years, and I don't know how many thousands of pounds. Proprietary code. Okay, you've got to be really careful with relying on proprietary code. So sometimes it's impossible to avoid. 17 years ago when we started, the on-screen manipulation we needed to do, the only application that we could achieve that in was Adobe Flash. There was nothing else. HTML just crashed the system with memory overload and all sorts of stuff. So we had to go with Adobe. It served us really well for 10 years. And as I explained here, the problem you've got is it doesn't matter what they say their roadmap is, right? Even if you can get a roadmap out of them, chances are it will change. And then eventually one day they'll just wave a flag and say, no more of this, sorry guys, over to you. So it coincided with HTML4, and that was sufficient for us to move across into JavaScript, CSS, HTML4, and replicate what we were doing in Flash in an acceptable way. But it took 2 years to be able to migrate that system across. And the one thing we did discover is that seamlessly migrating a system from Flash to HTML with the customer base and data in place over one weekend and getting away with it is quite a challenge. I've got a story I'll tell you about that later if anyone wants to hear this, and that relates to bandwidth, which relates to the SSL wrapper that goes around a ping that we use to keep the system alive in real time. I can tell it's a whole separate story which I can do later. That was really interesting. Okay, in the software, right, I nicked this from the internet, so if you want to read about long tail, go to nngroup.com. That's what the SaaS market looks like, however way you want to dice it up, that's what you're facing. So here are our big customers that buy 50,000 credits a year, and here are our little customers that buy 36 credits a year, not 36,000, 36, right? And most of our markets there, one or two are there and some are down there. And you have to price it and engineer it to appeal to the whole marketplace, because that's what gets you the diversity. But it's quite straightforward to do. It's great. Right, never underestimate test. I'll be quick on this. Test is our biggest overhead. Right? It drains us mentally, it drains us financially, it worries us, etc., etc. But there is nothing other than just getting a whole group of people and sitting them in a room and saying, use this new code. This guy here knows because he's done that with us. And it can be soul destroying, but it is actually the single most important thing we do. And no matter how many hours you put in, as soon as you release that code, within several minutes, a customer will phone up and say, I think I found a bug. And they normally have. So you need a diverse team, because the number of people looking at the product from different perspectives is what gives you the test result you really need. So the snake was, you always underestimate the duration it's going to take to test a new application. One of the secrets to our success was deploying Unfuddle. I don't know how many of you guys use Unfuddle. It's a debug ticketing system, and it just transformed the management. You know, we might put through, on a single code update, we might put through 100, 200 tickets of potential overlaps and bugs and stuff on that, and Unfuddle just sweeps it through. It's a great little program. It doesn't cost much. It's pretty cool. And interesting, never assume a bug is a bad thing. Sometimes a bug opens your mind to a different way of moving code forward. It reveals things that you wouldn't have thought about had that bug not manifested itself. Often leads to new features and functions, that sort of thing. And right, the final thing. Sustainability. We're starting a new project now. I can't tell you exactly what it is. If I come back in maybe a year's time, I probably can, but it's based around sustainability. Up until now, if you wanted performance, it's quite easy. Chuck in a few more processor cores, put in some more RAM, stick in another SSD, bump up your power supply, bump up your bandwidth allocation, away you go. Well, there's a hidden cost to that, and that's CO2 that's coming out of the power station that's driving the data center. So our focus now is on ultra low carbon development. And how are we going to do that? I don't know, we're working on it right now. We've got some ideas, and the next slide comes onto that. We're working on this hard to find out, but there is a legally binding 2050 net zero deadline that the government's put in place. So it will all eventually catch up with us at some point, in some way, shape or form. And already, you know, I'm starting to read in the news, they're demonising the data centres. You know, they're power hungry, they're cooling. I think that's probably going to intensify. And we're kind of part of that infrastructure. Which brings me on to the last slide, which is the techie bit, which I promised I would do, which is this, because one of the things we're doing is we've got to decide which language to use and which architecture to use, which hardware to use. So I thought, well, I wonder if anyone's researched the power consumption of a function in all of the different programming languages. right? And they have, right? Already done it, right? And so we went on to the new stack, and these guys go to that site and read this article, because this is just a screenshot out of a much bigger article. That's energy consumption, that's time, that's memory. They put, I forget, I think they did 10 different functions and ran them through all of these different programming languages. And it's fascinating because we're probably going to be in .NET C# on Linux or something like that. Now, we're going to be around here. So if the most efficient is one there in C, we're probably coming in at 3.4. The first iteration of our product 17 years ago was in Perl, which is 80. We didn't know that. This was only done a couple of years ago, right? I don't think anyone ever measured. But the interesting thing is, energy does not correlate to speed. Okay, the two don't map. You know, the lowest energy isn't the quickest, or the slowest. Right? There's no mapping there. But there doesn't seem to be any correlation in memory either. So it's peculiar. But up until C#, they're all kind of I don't know what you call those. You know, Ada, Pascal, Chapel, they're all kind of what do you call them, firmware type languages. Yeah. You know, it's only when you get, you know, we're going to be a web application, so it's only when you kind of get down to here that it means that PHP's not looking great at 30. Where's JavaScript? Yeah, well, actually, yeah, big jump. It's weird, isn't it? You go from Racket there, 7.9 up to suddenly jumps to 21, but don't ask me. I'm imagining this is going to get quite popular. Yeah, anyway, that's kind of where we're starting. So if you invite me back in a year's time, I might be able to show you an implementation of the type of ultra efficient, low energy, low carbon code we're trying to work on. And the development team I'm working with, they also work in industrial and medical. And so again, every single byte of information it consumes energy, it's an opportunity for error, it's a payload, and those guys are kind of pre-programmed to try and limit that. And that's it. So, yeah, there we go. Any questions? Any questions? Yes.
If you're looking at energy efficiency, so as you said, programming languages.
Yes.
Hardware.
Yeah. Oh, yeah.
So modern architecture, RISC-V.
Yeah.
What are you looking at?
You're asking the wrong person. The development at the moment, when I spoke to them last, I'm kind of out of my depth, but where we were testing stuff was .NET C# on a Linux server, and that was our start point. Okay? But what's going to happen is that the analysis of the hardware and the environments and the programming language is going to have to be continuous, because I'm imagining the whole sector is going to move in that direction. Now, I was looking at Google Carbon. I don't know if you looked at Carbon. Yeah, you know. And why is it called Carbon? Is it just a great name, or is it supposed to be low carbon? I don't know. Yeah, that's just going to, my development team is just going to have to work on that. Essentially, it becomes our number one priority. So that's at the top of the list, and then once we've decided upon that, then we move on with what comes next. I don't know if that's a common thing. I don't know if you guys are doing that already. I don't know if other people are doing that. But we've just decided that that's what we're going to do. And one of the huge benefits, obviously, is speed. It's the bits that we've done so far, just lightning fast, super fast. But it takes a different mindset from both the developer and the end user. Yeah.
There is also a kind of a you can have something run fast and give you a result quickly.
Yeah.
Something that's quick and efficient, but it doesn't necessarily give you
That,
result quickly.
absolutely. Yes.
To spread out load and give you
Yes.
lower power by not having to have massive spikes, because most computers don't perform well
Yeah.
when they're working pretty hard.
Yes.
So
Yes.
is there somewhere along that line?
Yeah, ultimately we're going to look at everything. I'm working, part of this project is involving the University of Kent, and it's on a much bigger sustainability project, but I'm hoping to pull some of the guys in from there, and we're just going to have to do our homework. It's as simple as that, and do the best we can, work within our limitations, because there will be practical limitations. But probably the most important thing is the applications, the front ends, are not going to look like the front ends that our users expect to see. Okay, we'll run with system fonts. We're not going to download font libraries and stuff like that. Well, that's not what our users, customers are used to. The images we deliver are not going to look like the images they expect to see, right? But it's there for a reason, and that's the direction we're going to move. Will everyone? I don't know. It depends how the government punishes taxes, etc. in the future, according to the net zero status of the business. And it'll be a life cycle analysis. Hi.
Do you think there's going to be a trade-off between efficiency and maintainability?
Oh, maintainable. Well, do you know what? It's interesting, because when I spoke to the development team about this, they were delighted by the idea due to the simplification of their code. So in terms of maintainability from a code perspective, I don't know. It didn't sound as though it was. Hardware-wise, I'm not sure, because low energy hardware may emerge at a much more rapid pace. How that will impact us, I'm not sure. A lot of people are saying, well, the data centres, they can switch to renewable energy, so you're kind of net zero from day one. But the reality is, renewable energy is a limited resource at the moment. It's scarce, so you don't want to waste it. It's not an energy source you can just waste just because it's renewable. It needs to be protected and used efficiently as possible. And so the days of just throwing capacity at the data centre, I imagine, will eventually kind of grind to a halt. It's like, I work in the publishing industry as well, and digital publishing allows you to just push out bigger files, multimedia files, etc. to a wider audience. But in the days of print, when you knew the price of every sheet of paper and every page printed, and you knew the weight of every page because it cost you, you would never publish and distribute a single page more than you needed to get that message across. And it's a little bit confusing with ChatGPT and AI, because they're about to create huge volumes of content that never existed before, for good or bad, and every single one of those words comes with a carbon payload in terms of its creation and delivery. So on one hand, we're trying to optimise and limit that data. On the other side, the AI guys are trying to produce more, and somewhere in the middle, it's not adding up. But anyway, yeah.
Well, I've got a question.
Oh, yes.
So I can't remember which slide it was, but you mentioned about how bugs aren't a bad thing because they reveal
Yes.
things. I feel like there's a story behind that.
Oh, yes. There's
What
loads of
things have you
stories
learned?
behind
Yeah.
that. Oh, yeah. It is. I'm trying to think of an actual case study, an actual application. Right off the top of my head now,
Sorry.
I can't. But what will happen is a bug, typically when a user finds it, because they'll say, I didn't expect the system to work like that. I expected it to work like this, right? So the bug introduces like a trip hazard, right? They can fall over it. That causes them to call us to find out whether, because not all bugs crash the system, they sometimes just make it behave in a peculiar way. That triggers them to give us a call. We'll say, oh no, it shouldn't work like that, it should have done this. And they'll go, that's a bit weird because that's not how we expected it to work either. Right? Wouldn't it be much better if it did that? We go, yeah, you're right. Yes, yeah, you're 100% right. Yes, we'll do it like that. And so the bug fix becomes a function adjustment. And that happens really quite, well, not every day sort of thing, but it's quite a common occurrence. Yeah.
Okay.
And so the customer becomes the designer based on how they perceived how they perceive the bug. It's quite interesting. And, yeah. Yes. Sorry.
I'm not business savvy, but how do you acknowledge a sort of market space and a proof of concept, and like how do you because it costs a lot to build something, right? How do you know there's going to be like a market for it? How do you know what to build, and then how do you market that for people to use it? Like how does that bootstrapping work? Identification marketing.
Okay, right. Here's my rubbish business plan. Right? If you go to a bank and you say, I'd like to borrow some money to build this application, and they say, okay, who's your competitors? You say, well, there are no competitors because it's brand new. You go, okay, will it work? You say, well, I think it will, but it might not. They say, how big's your market? We say, I have no idea because the market's never seen it before, right? They'll say, you need to go away now because this isn't going to happen, right? So, your options are, if you're the developer, happy days, because the primary cost, 80–90% of a minimum viable product is development cost. So if you are the developer and you're covering your own costs, you've already broken 90% of the task. Okay. Then what you do, or what we do, is you build something that demonstrates what you imagine the problem and solution is, and you then spend £1,000 on the smallest stand you can buy at the exhibition where all of the potential customers will be, right? And then you show it to people, and you'll get a feel for whether people like it and whether they'd be willing to pay money for it, how many of them there are, and what you've done that's stupid and what you've done that's good and that sort of thing. And then that's where my stupid business plan kicks in, which is how we do it, which is how many people are there in the world, 7 billion or whatever it is. Could we find 100 people willing to spend £50 a month on what we've done? Okay. And if you could, what's that, £60,000 a year? Something like that? Well, that's enough, surely. Just to kickstart the plan, right? And that was my business plan, because everyone said to me, write a business plan, and I said, what? For a product that doesn't exist, that might not work, for a market that might not want it, how do you write a business plan like that? Well, you can't. No. You can sometimes you can crowdfund, you can go for grant applications if it's in a specific area, you can risk your own money, I guess, up to the limit, but mainly just risk your time. And at the end of the day, and the other thing is just build a web page, with a registration button or whatever it is. The new product that we're building now, we went to a manufacturing exhibition 2 weeks ago. We handed out flyers, and we had our first registration yesterday. Right, and if you can sell one, right, a top salesman taught me this, right, one of my biggest mentors. You can sell one, you can sell two. So sell two, you can sell four. If you can sell four, you're in business. And that's our business plan. And everyone thinks it's rubbish. No, they do. They literally do. No one in their right mind would say that is a business plan. But actually, I think it is. And if you're doing the code, you know, I don't code. I watch people code. I sort of generate systems and strategies and that sort of thing. I wish I could code because that's the 80% of the job. So I have to buy in the 80%, but if you're the developer, all you have to do is buy in the 20%, which is the marketing and accounts and that sort of thing. So it can be done. You know, even if you just got drawings, you could even just take drawings to some. I've done that. Use something like balsamic, or we use balsamic for line wireframe. We use Zeppelin for UI UX development. Get a Zeppelin guy in, design up your interfaces, show them to people, get feedback, do a minimum viable product. Most exhibitions in the UK, £1,000 will get you a little stand. Probably less than that, to be honest. A couple of pull-up banners, run it on a laptop. Keep your fingers crossed. Yeah.
Just on a business, your SaaS model,
Yeah.
where people are buying credits.
Yes.
Are they locked into a time period? Because the time period was always theoretically the beauty of SaaS.
Yes.
I think you've gone another route.
No, what we do, it's interesting. We decided that the future of our product was based on collaboration.
Right.
And the problem with packages is they typically limit your users.
Right.
So we worked out a different way where, because it's a magazine planning tool, we thought, what if we sold you a credit and each credit was equal to one page of your magazine?
Right.
So as you plan a magazine, if you plan a 32-page magazine, it consumes 32 credits. When that magazine's published, those credits are then archived,
Right.
and you need to buy another 32 credits. And what if we allowed people to buy 100 credits and then use them across a year, or sign up for 50,000 credits and pay monthly, or buy them in batches, whatever. Super flexible payment process. It means that we can supply the biggest publishers in the world, as well as like church newsletters, and we do. And that's why
And this is print magazine?
Print and digital page turning style magazines. It's just a planning tool. It's just a collaborative project management tool. When you publish a magazine, if it's say a 100-page magazine, there's probably 1,000 decisions need to be made over 20 days, and you need to get every one of them right in sequence. So it's just a tool for that.
So they're locked in by the efficiency of the tool. Is that it?
Yeah, our customers that signed up 17 years ago are still our customers. We've never spoken to them.
Best customer.
So you mentioned,
Yeah, sorry.
You mentioned you only got 2 or 3 people. You're only in the company. You only got 2 or 3 people.
Yes.
How does that work? Supporting a SaaS product that is obviously out there.
Yeah.
Have you got a technical person in the company?
No, we have a technical
You buy
team.
it
Same technical team we started with 17 years ago.
Wow.
So it's separate to us, but there is we've got a financial agreement with a long-term agreement. Basically, there's a sort of profit share type arrangement to make sure they're interested in us and we're interested in them type thing. Yeah, you know, there will be the occasion where the server falls over. You know, it happens. It happens for Facebook and Twitter and everyone else, and that. So it does happen. You then need to go into like an emergency mode. So you need people available 24 hours a day, 7 days a week in one way, shape or form. But normally it's the data center that manages the emergency events. And really then what will happen is the system will go into a dwell period, and then there'll be a bit of activity around a new feature launch, where everyone suddenly comes together and we work for several months effectively as one company, introduce that product, debug it and a feature, and then smooth out again. We're about to put a new API into place. So we can connect to like Salesforce and things like that. That's going to be quite dramatic. That's what's it called? It's an authenticated RESTful JSON API, which I'm told is the nice new shiny version. And we'll probably finish that in 2 weeks, and then that will roll out over the 2-week period.
And so you mentioned about user testing as well, or testing but with real users.
Yeah.
That's great.
Yeah.
But do you have? I take it you've also have full test coverage, automated tests as well.
At the development stage, but once you get to, we've got 3 servers. Okay, we got 4. Yes, development server, test server, beta server, production server. The automated test is taking place on the development server. The manual test is taking place on the test server. The client test is taking place on the beta server, where we've got a subset of customers that know they're on the beta server, so they're expecting to work with us. And then we've got production, and it'll be about a week on the test server. Manual test could be up to a month on the test server. Beta, normally our customers find something within about 30 seconds. So it doesn't stay on the beta test server for long. About say a week, they'll find everything within a week, and then it just goes over to production, and that's it.
So your time to market is actually quite a long period from when you launch a feature, you start a feature to actually launching it.
Oh yeah. I mean, the API would be, from the guys laying down the sort of first line of code to us actually releasing it on the production server, 3 or 4 months, something like that. Yeah. But a lot of the delay is the manual test, because then we have to go through, because what happens, go through manual test, find a bug, resolve it. The problem with resolving the bug is that you then potentially introduce another one.
Yeah.
So it's you don't nudge your way along, you stop and go back to the beginning. Essentially, there's no other way of doing it. And the bigger the system gets, the greater the probability of an unintended consequence somewhere completely unrelated. It's I can't describe it really. I mean, it's
But that's where automated tests, like automated acceptance tests, would actually find benefit from those.
Yeah.
You're writing tests around what you expect to happen, and therefore, and it covers everything.
Yeah.
Therefore, you're not.
I don't know. Normally, the user found bugs. For example, one thing that would happen would be due to latency. So if we run the data center in the UK, and we have customers in Australia. So the latency of that operation can uncover a bug that we can't find in the UK. Now, whether automated tests, we have tried a method where we can overload processors, overload power supplies, overload memory, and everything to see whether that triggers stuff. We can restrict the bandwidth. So sometimes we go through bandwidth restrictions to see whether that triggers anything. But yeah, I don't know. I don't know whether our product suits that level of automated test. Maybe not. I'll have to investigate that further. Yeah. Sorry.
Seriously, am I right to put that, guys?
Yeah, sorry. Yeah.
Thank you.
Is that right? Yeah.